So we will start at number 6 all the way here. So for number 6, we have 18x squared minus 8y squared. Now remember that we are now factoring. So we still want to factor into 2 first. But we only have 2 guys. So you gotta remember, when you factor, always start with the easiest factor, which is they're both even. So 2 can go in there. Wouldn't that be 9x squared minus 4y squared? That's probably the easiest part of the factoring. Then you gotta think about, well, this is a binomial formula. This is a situation with the a squared minus b squared is a plus b times a minus b. So as long as we can have this, then we're good to go. So for this guy, you want the first term to become something square. But you're like, wait a minute, 9 is 3 squared. So wouldn't that just be 3x squared like this? And 4 is 2 squared, right? So that'll be 2y squared. So just like that. And then now you notice this is your A and this is your B. The 2 is just gonna stay right outside. So by this formula right here, you should get A plus B and A minus B, right? So you just gotta fill in the blank. Take 3x and 2y, put it right here. And then put it right here. And that's it, that's the answer. It's easy if you know the formula. The difficult part is to understand, you're gonna use that guy for number 6. So in the formula sheet, you're more than welcome to write this down. Just write down the formula, a squared minus b squared, right? And you can put next to it, say, that's for number 6. Because on a midterm exam, I keep the order for problem. So are there any questions about this? Number 7. So now for this guy, number 7, this is one of the tougher problems of this midterm. And the reason is you have to figure out what are the square for 192, 48, and 75? Can you find a perfect square within those guys? And the way I see it is this. 75, isn't that 3 times 25? Do you believe that? And I recognize 25 is a perfect square. Now what about 48? 48 is 3 times 16. 16 is also a perfect square. Now you may not know the right way, but you can play around with 75, right? See what number can go into. Same with 48. Use a calculator, right? Just divide by 2, 3, 4, 5. See what you get, right? But you know where this is going. This guy has a 3. This guy also has a 3. So this guy right here must also have a 3. Well, 3 goes in there how many times? Well, let's see. 3 goes in there 64 times, which is also happen to be a perfect square. Now, for the second step, you guys can skip it if you want to, but I'm just gonna write the whole thing now so I can explain what's going on. I'm just gonna write this. Basically, I replace all the numbers within the radical with the factorization I just showed you, right? I just break it up. Then I would say, okay, radical 64 is 8. And 8 times 2 is 16. So I get this guy as my first term. And I want to pause for a second just to make sure everybody's okay before I continue. But that part, I skipped a step. Are there any questions? Now look at this. What is radical 16? That's 4. 4 times 9 is 36, right? And then plus, what's square root of 25? It's 5. 5 times 15, what's 5 times 15? Is it 75? Yeah, 75. Just like this. And now you see this, right? We have the like terms. Everybody's got like, I love like terms. Like terms means you put them together. Negative 16 minus 36 is negative 52. Negative 52 plus 75 is what? Positive 23. So that's 23 radical 3. That's it. That's the answer. Just like that. And that's number 7. So let's look at number 8. Oh, so didn't we do number 8? Yeah, we did number 8. So that refer back to your notes for number 8. So if you want, you can ask me after class if you don't have. But number 8 is we did that in class already from the last from the day before the 1.9. So we can go back to it later. So let's do number 9. 8t minus 9 bigger than 4 plus 10t. So for this guy right here, it's not too difficult, it's just easy to forget because we haven't done inequality for a little bit. So the game is this, right? You gotta bring all your t's to the left hand side. That's how I usually do it. Minus 10t. And I will add 9 to both sides. So now you get negative 2t, and that's 13, right? And then you divide by negative 2. And remember, anytime you multiply or divide by a negative number, you're gonna flip-flop the inequality. So now you should get t less than, and you can just do decimal number, negative 6.5, right? So that's the answer, but you have to expand on that. Because for number 9, you do have to draw the line for the inequality, for the graph. So the graph should be like this. Right here is 0, right here is negative 6, and right here is negative 7, right? Negative 6.5 is in between those two guys. Now this guy says less than, not less than or equal to. It doesn't have the equal sign here, right? So it will be a parenthesis like this, going towards the left, because it's less than. So the answer will be negative infinity, comma, and you stop at negative 6.5, parenthesis. So collectively, these are your answers. So my question would be, you might be wondering, hey, what if I got this correct and I got the rest incorrect? If you can give me this guy right here, that's 2 points. Give me this guy, that's 3 points. Give me this guy, then that's 4 points. So I want everything, but I understand if you don't get everything right, if you at least solve inequality, okay, I'll give you some credit. Now, number 10 is another quadratic formula problem. the first thing I will do is I will bring everybody here to the left. So that will be 3y squared plus 2y plus 2. You're gonna add those two guys to the left. Now some people say, hey, can I do the AC method? Well, AC method means 3 times 2, that's 6. Well, 6 is not gonna give you a factor that can get to 2. Right? It's 1 and 6 and 2 and 3. So you have no choice but to use the quadratic formula. So that's A, B, and C, right? So they just got to plug in. Negative 2 plus or minus radical 2 squared minus 4AC. And it's all over 2 times A. Right. It's got to grind this out, right? This one is tracking, just grind. So that's negative 2 plus or minus. That's 4 minus 4 times 3 is 12. That's 24. Oh, that's right. Over 6. Do it step by step, right? 4 minus 24 is negative 20. Like this. And remember, if you have a negative, what do you must do? That negative will go outside the radical. It will become a good old I. So that will be negative 2 plus minus radical 20 times I. Just make sure the I is outside of the radical. And I'll tell you what, if you can give me this guy right here, man, you know what? I'm gonna just give full credit. I'll just give full credit for this one. But to get the full answer, the fully correct, or the full answer that I really want to see is, notice that 20 right there, isn't that 4 times 5? 20 is 4 times 5, right? So radical 4 is 2. Like this. Radical 4 is just 2. And you have a 5 left over inside a radical. And notice that, look at the 2's and 2 and 6. They can all be divided by 2, right? You can simplify that. So that becomes 1, 1, and 3. So the true answer is negative 1 plus or minus radical 5, I, all over 3. And keep in mind that that 1 times radical 5 is just radical 5, right? You can put a 1 in if you want to. It doesn't change the answer. I just choose not to write. And that's the answer for number 10. But if you can give me this, I'll be nice and be correct, okay? Now, don't give me, if you give me this, I'll take a point off. Right, because the negative, I expect you to know. Negative inside a radical, that should give you an I. With this guy, and the reason why I don't really care at this point is because, listen man, if you're gonna become, let's just say you become an engineer, or economist or whatever. Well, economists don't do this, but engineer. You gotta put this in the calculator. Radical 20, you put in a calculator, you get a decimal. Then you're good to go. Only, and also in science, the same way. Science don't do radicals and stuff like that. I mean, you do radical, but you're not gonna manipulate it. Only, this is only for, and I hate to say this, only for mathematicians. This is just for math people. Like this, from this to here. In some classes, in pre-calc and calculus, a lot of instructors simply don't even care if you simplify. It's also got the answer. Now let's look at number 11. So number 11 is 5 radical 2 minus 3 radical 7 times 2 radical 2 plus 9 radical 7. Now for this guy, you gotta think about this. It's really not a difficult problem, just a lot. You just gotta pay attention to detail. You are doing the foil. So when you do the FOIL, what happens? Is the first term, right? 5 times 2 is 10. What's radical 2 times radical 2? Remember this radical 4 and then 4 radical 2 is 2? Or radical 4 is 2? Basically, if you multiply radical 2 times radical 2, you're just going to get 2. So that's that first term. Now what about the outside terms? Right? Outside terms would be 5 times 9, which is 45. Radical 2 times radical 7, that's radical 14. I like that. So everybody outside of radical get together, everybody inside of radical multiply together. Now let's look at the inside terms. That's minus 3 times 2 is 6, right? 7 times 2 is 14, radical, right? And the last term, that's minus 3 times 9 is 27. So that's 27. And then radical 7 times radical 7, it's just 7. And now look, these are like terms. These are like terms. So 10 times 2 is 20. Plus 45 minus 6 is plus 39. And then minus what's 27 times 7? 49. 189. 189. And now you just got to combine the like terms again. 20 minus 189 is negative 169. Plus 39. And then radical 14. And that's it. So let me laugh, it's not so bad. It just, you have to be careful. So I gotta check on the phone to make sure it's still recording. I'm scared now after what happened last time. Maybe that's standards I gotta do. That won't recall for a long period of time. Number 12. So number 12 is easy if you know what to do. But if you don't know how to do it, there's no way you can just like grind it out or anything like that. So anytime when you have third power, I'll be careful with this thing because the first thing I'll look at is that 270. Well, 270 is either, I mean, you can list all the numbers if you want to. That's 2 times 135. That's 3 times 90. That's 4. Doesn't go in 5 goes in there. That's 4. Let me say 5. 54. And then 6, 7. Can 6 go in there? Yeah, 6 go in there. You can use a calculator, right? 6 goes in there. 45 times. 7. No. 8. 9.
30.
30.
930.
930. And that's also 10 times 27, right? I think that's all. Now, why do I write all these numbers down? This time we don't have a square roof. We're not looking for the perfect square. We're looking for the perfect cube. Remember, we list all the numbers on the cube, like 2 to the third power is 8, 3 to the third power is 27. Well, we have one of them up in here now. There's only one cube up in here. That's this guy. 27 is 3 to the third power, right? In other words, the cubic root of 27 is just going to be 3. So those are the little things you're looking for. So in our case, here's again, there will be the cubic root of 10 times 27 times x to the 9th power times y to the 10th power. Then you're like, okay, 10, you're stuck. There's nothing you can do. So we're gonna open up this radical and put a 10 in it. 27, well, we just demonstrated, that will be 3. Now, when you do the variable side easier, 3 goes into 9 3 times. That's x to the third power. 3 goes into 10 3 times, so that's y to the third power. 10 minus 9, that the remainder is 1, right? So it'll be y to the first power, right? That's pretty much it. That's the answer. Now, some of you guys might say, hey, I wish I could just do the x and y. That 270 was more difficult, right? I'm going to show you a different way to solve the same problem. Maybe you like it, maybe you don't, right? Just pick the method that you like the most. So I want to solve number 19 again, or number 12 again, alternatively, alternatively. The cubic root of 270, x to the 9 power, and y to the 10 power. So here's what I would do this time. Instead of looking for the pairs of factors, I am going to look at the prime factorization. Remember the factor tree that we're going to do way back? Maybe in third grade, whatever. That's 27 times 10, right? That's 3 times 9. And 9 is 3 times 3. 10 is 2 times 5, right? Are you okay that once you break this guy down all the way to the bottom, you get 3 to the third power, 2 to the first power, and 5 to the first power? That's what 270 is, right? So instead of 270, I will write the factors. So that will become the third power, or the cubic root of 2 to the first power, 3 to the third power, 5 to the first power, x to the 9th power, and y to the 10th power. Running out of space. Like this. So you're like, okay, well, what am I going to do now? You are going to look at each one of these guys as an individual unit. So like this is, treat that like an x, y, z or something. So you got to do the same thing. You're still going to do the cubic root over here, right? You know what, maybe let me give more space at the bottom. Here. 3 does not go into 1. So that's a 2 left over. 3 does not, 3 goes to the 3, right? So that's 3 to the 1 power. 3 does not go to 1 here. So there's a 5 to the 1 power left over. 3 goes into 9 3 times. So that's x to the third power. 3 goes into 10 3 times. So that'll be y to the third power. But 10 minus 9 is 1, right? So you got a remainder as y to the first power. That's the answer. If you leave it like this, I would take it. But you can clean it up a little bit. 2 times 5 is 10. So that you get the same answer as the other way. So it's all up to you how you want to do it. Some people like this way better, some people don't. So what do you guys think about, which way do you prefer? Do you like the second way? Or you guys like the first way? The first way is faster? Or they just hard?